Today we cover the Physics Chapter Sound CBSE Class 9. Introduction. Sound is a type of energy. Sound travels in the form of wave from one place to another. Production of sound. Sound is produced because of the vibration of any object. In other words, when an object is vibrated it produces sound. Example. Sound can be produced by clapping of palms. Sound can be produced by vibrating a string. Sound can be produced by beating a table or diaphragm of a drum. Sound is produced by a flute because of vibration of air column. Sound is produced by a guitar because of vibration of its string. Thus, an object is needed which could be vibrated to produce sound. Propagation of sound. When a stone is dropped in pond water, it produces many circular wrinkles and water appears to be traveling outwards from center. These circular wrinkles are called ripples. This happens because of formation of waves in water. When a stone is dropped in water, it creates a disturbance in water particles. The water particles pass the disturbance to the adjacent particles and the adjacent particles pass the disturbance to the next adjacent particles and so on. This phenomenon continues and the disturbance moves outward from the center of disturbance. This makes water appear to be moving. In fact, water molecules do not travel in this case, rather only the disturbance is passed through particles of water. This creates wave in the form of ripples in water. Sound travels from one place to another in similar manner, i.e. through wave formation. In this case, the particles of medium do not travel, rather only the disturbance, caused by sound energy, passes to the adjacent particles of the medium. So, the traveling of sound is called propagation of sound. Thus, sound propagates from one place to another in the form of waves, i.e. because of the disturbance of particles of the medium. Wave, sound wave. The disturbance or oscillation from one location to another location, accompanied by transfer of energy, is called wave. There are two types of wave, viz. Electromagnetic wave and mechanical wave. Electromagnetic wave, wave that requires no medium to propagate, is called electromagnetic wave. For example, light wave. Light can also travel through vacuum. Mechanical wave, wave that requires medium to propagate, is called mechanical wave. For example, sound wave. Sound cannot travel in the absence of a medium. Types of wave. On the basis of direction of propagation, waves can be divided into two types. Transverse wave. Longitudinal wave. Transverse wave, the wave formed because of the oscillation perpendicular to the disturbance, is called transverse wave. For example, light wave, water wave, etc. In transverse wave, particles oscillate in up and down directions, relative their normal position of rest. Particles of medium create elevation above the normal position or line of zero to the surface of medium and depression below the normal position in the course of oscillation. The elevation is called crest and the depression is called trough. Longitudinal wave, the wave formed because of the oscillation, parallel to the disturbance, is called longitudinal wave. For example, sound waves. A use of forward and backward movement of particles of the medium. If a slinky is pushed and pulled backward and forward, the wave formed in slinky is similar to longitudinal wave. Sound wave is longitudinal wave. Sound propagates because of oscillation of particles of medium parallel to the disturbance, thus sound wave is longitudinal wave. Compression and rarefaction. When a slinky is jerked to and forth, two phenomena take place simultaneously. First, the coils come closer to each other while, on the other hand, some of the adjacent coils go farther from each other. This phenomenon continues and the wave goes forward. The action when coils come closer is called compression and when coils go farther from each other is called rarefaction. When sound wave travels through a medium, say air, the particles of medium disturb in the same fashion, i.e. compression, and rarefaction, depression. When air particles come closer it is called compression. On the other hand, when particles go farther than their normal position it is called rarefaction. This is similar to the compression and rarefaction produced in the slinky. In the condition of compression, molecules of medium come closer to each other, and in the condition of rarefaction, molecules of medium go farther from each other, compared to their normal positions. Density, pressure, and disturbance. When compression takes place in the medium, the density and pressure of the medium increase. When rarefaction takes place in the medium, density and pressure of the medium decrease. This increase and decrease in density and pressure are temporary. Thus, compression is called the region of high density and pressure. Rarefaction is called the region of low density and pressure. Production of sound in laboratory. In laboratories, sound wave is produced by striking a tuning fork over a rubber pad. When prongs of the tuning fork are struck over a rubber pad, the prongs of tuning fork start vibrating and produce sound. One can feel the vibration of prongs by touching them after striking over the rubber pad. The vibration produces sound energy. This sound energy creates disturbance in the medium by making compression and rarefaction, and the sound wave propagates forward. Characteristics of sound wave. Following are the main characteristics of sound wave. Wavelength, amplitude, time period, frequency, velocity, speed. To discuss the characteristics of wave, a graphical representation of sound wave is considered. The peak of a wave is called compression or crest. The valley of a wave is called rarefaction or trough. Wavelength. Wavelength is the length between two consecutive peaks, i.e. crest, or two consecutive valleys, i.e. trough of a wave. Wavelength is represented by Greek letter lambda, lambda. Louder sound has shorter wavelength and softer sound has longer wavelength. The SI unit of wavelength is meter, m. Amplitude. Magnitude of maximum disturbance on either side of the normal position or mean value in a medium is called amplitude. In other words, amplitude is the distance from normal to the crest or trough. Amplitude is the energy of sound. Louder sound has greater amplitude and softer sound has shorter amplitude. Thus, louder or softer sound is determined by its amplitude. Since louder sound has greater energy, consequently greater amplitude, thus it travels to a longer distance. Softer sound has smaller energy, consequently shorter amplitude, thus it travels to a shorter distance. Amplitude is denoted by letter A. The SI unit of amplitude is meter, m. Time period. Time required to produce one complete wave is called time period, or time taken to complete an oscillation is called the time period of the sound wave. In other words, time in which a wave moves a distance equal to its wavelength is called time period. The time period of sound wave is represented by letter T. The SI unit of time period is second, s. Frequency. The number of sound waves produced in unit time is called the frequency of sound waves. For example, if a source of sound produces 20 sound waves in 1 second, then the frequency is 20 Hz. Time taken to calculate frequency is in second. Frequency is denoted by Greek letter nu, nu. The SI unit of frequency is Hertz. This name had been given after the German scientist Heinrich Rudolf Hertz. Relation between time period and frequency. If one sound wave is produced by a source, in t second. Therefore, in 1 second number of wave produced equals 1t equals 1t. Since, frequency is the rate of production of wave. Frequency equals 1t, frequency equals 1t. Frequency equals 1 time period, frequency equals 1 time period. V equals 1t, V equals 1t. Where, nu equals frequency and t equals time period. Thus frequency is the reciprocal of the time period of wave. This means the frequency is increased with decrease in time and vice versa. Velocity. Distance covered by sound wave in unit time is called the velocity of sound wave. Velocity equals distance time taken, velocity equals distance time taken. If distance equals lambda and time equals t, velocity equals lambda t, velocity equals lambda t. Or, v equals lambda t, v equals lambda t dash dash, I. SI unit of lambda is meter, m, and SI unit of time is second, s. Therefore, SI unit of velocity equals ms1 equals ms1. Therefore, velocity can be defined as distance traveled per second by sound wave. Since, frequency, nu, equals 1t, frequency, nu, equals 1t. Therefore, equation, I, can be written as v equals lambda t equals 1t equals nu lambda, v equals lambda t equals 1t equals nu lambda. V equals nu lambda, v equals nu lambda. Where, v equals velocity. Lambda equals wavelength. And nu equals frequency. Thus, velocity of sound wave equals frequency x wavelength. This is called wave equation. Wave equation is applied to all types of waves. Thus, velocity of sound wave is the product of frequency and sound wave. Quality of sound. Timbre. The quality of sound is called timbre of sound. Timbre is one of the characteristics of sound that enables us to differentiate between two different types of sound. Because of timbre, the sound of flute and harmonium or other musical instruments can be differentiated. For example, the frequency of a particular note do or SA produced by all the musical instruments is equal. In spite of that, because of different timbre, one can differentiate the sound of same frequency of different musical instruments. Different persons produce sound of different timbre. Because of different timbre in sound, the voice of different persons can be recognized. Tone and note of sound. Sound of a single frequency is called tone and sound of mixture of several frequencies is called note. A note is pleasant to listen. Noise is unpleasant to hear. Music is pleasant to hear because of good quality, i.e. timbre, while noise is unpleasant because of bad quality. Medium is a must for propagation of sound wave. Since sound wave travels by the compression and rarefaction of the particles, so a medium is necessary for propagation of sound wave. Sound cannot propagate without a medium. Sound wave cannot propagate through vacuum. This can be demonstrated using the bell jar apparatus. When all air is vacuumed out of bell jar, the sound of the bell is not heard outside. This happens because there is no medium present, consequently no particles present for compression and rarefaction in the bell jar through which sound waves could propagate. Propagation, traveling, of sound through different media. Sound propagates through solid, liquid and gas. In all these media, sound wave propagates by the compression and rarefaction of particles of the medium. Velocity of sound wave in different media. The velocity of sound waves depends upon the following three factors. Nature of the medium. Temperature. Humidity present in air. Nature of medium. The velocity of sound is maximum in solid, moderate in liquid and minimum in gas. For example, temperature. The velocity of sound is directly proportional to temperature. This means, velocity of sound increases with increase in temperature. For example, sound wave at 0 C in air is 332 m/s. The velocity of sound waves at 20 C in air is 344 m/s. This is the reason we hear more clearly on a hot day than on a cold day. Stethoscope. Stethoscope is used to hear the sounds of internal organs of a patient, for diagnostic purposes. It works on the laws of reflection of sound. In stethoscope, sound is received by chest piece and sent to the earpieces by multiple reflecting through a long tube. Doctors diagnose the condition of an organ of the human body by hearing the sound using the stethoscope. Stethoscope has become the symbol of the medical profession since its invention. Humidity present in air. Since velocity of sound wave in water is more than that in air, so humidity in air increases the velocity of sound. Therefore, an increase in humidity in air increases the velocity of sound and a decrease in humidity in air decreases the velocity of sound. This is the cause that we can hear more clearly in rainy season than in summer. Reflection of sound. Sound wave also gets reflected as light waves do. Bouncing back of sound wave from the surface of solid or liquid is called reflection of sound. Reflection of sound follows the laws of reflection as light wave does. This means the angle of incident wave and reflected wave to the normal are equal. For reflection of sound, a polished or rough and big obstacle is necessary. Use of reflection of sound. Reflection of sound is used in many devices. For example, megaphone, loudspeaker, bulb horn, stethoscope, hearing aid, soundboard, etc. Loudspeaker, megaphone, bulb horn. Loudspeaker, megaphone, and bulb horn are devices used to send the sound in desired direction without spreading the sound all around. These devices act on the laws of reflection of sound wave. In such devices, a funnel-like cone-shaped tube is used. Sound is introduced at the narrower end of tube and let to come out from wider end. Because of successive reflections, the amplitude of sound is added up, which makes the sound louder. The name loudspeaker is given as it is used to make the sound louder. Soundboard. Soundboard is used to send the sound towards audience in big hall or auditorium. This works on the basis of laws of reflection of sound waves. Soundboard is a big concave board and is set in such a fashion behind the stage that speaker is at the focus. Sound coming from speaker falls over soundboard and gets reflected towards the audience. As a result, the audience sitting in the hall even at far distance from the speaker can clearly hear what the speaker is saying. Additionally, the ceiling of the auditorium is also made curved so that it also acts like soundboard. The curved surface of the ceiling reflects the sound waves and facilitates better hearing. Echo. The sound which we hear after reflection is called echo or echo of sound. One can hear the echo by shouting loudly in a big hall. After shouting loudly, the same sound reaches the ears after reflecting from the surface of the wall. Echo of sound can be heard by producing sound at place surrounded by hills or big buildings. Thus, repetition of sound because of multiple reflection of sound wave is called echo. Condition necessary for creation of echo. One does not experience any echo sound in a small room. This does not mean that sound does not get reflected in a small room, but necessary conditions for production of echo are not present. Any sound persists on one's brain up to 0.1 second of time. So echo can only be heard if the same sound comes to one's ear after a lapse of 0.1 second. Thus, reflection of sound must reach to the brain after a lapse of 0.1 second. Explanation. Since sound covers 344 m in air in 1 second. Thus, in 0.1 second sound would cover a distance of 344 m x 0.1 equals 34.4 m. Thus, to hear an echo sound the reflecting surface must be at a distance of 17.2 m, so that sound has to cover a distance which is more than 17.2 m x 2 equals 34.4 m, before reaching the ears. So, if reflecting surface is at a distance of more than 17.2 m, the sound would reach to our brain after 0.1 second and we would be able to hear the echo of sound. Thus, there are two conditions to experience the echo of sound. A. Sound must come back to the person after 0.1 second. B. For above condition, the reflecting surface must be at a minimum distance of 17.2 m. Multiple echo. You may have heard the echo of your Yahoo in hilly areas. This happens because of multiple reflection of sound wave and is often called multiple echoes. The rolling sound of thunder is heard because of the multiple reflections of thunder sound or multiple echoes. The sound of thunder comes to us many times because of reflections from clouds and earth surface. Use of multiple reflection of sound. A. In measuring the depth of sea/ocean. B. For the detection of the position of any objects, such as shipwrecks, sea rocks, hidden iceberg in the sea and ocean. C. Investigating any problem inside the human body. For above-mentioned purposes, sound of high frequency is produced so that reflections can be received from various surfaces. The time taken for reception of reflected sound waves is analyzed by a computer to detect the problem. Reverberations. Persistence of sound wave for a long time because of multiple reflections is called reverberation. Usually, this happens in big halls. Sound becomes too blurred and distorted to be heard in big concert halls because of reverberation. This can often lead to annoyance. To overcome this problem, sound-absorbent materials, such as curtains, plant fiber, compressed fireboard, carpets, etc. are used in the auditorium. These materials absorb undesired reflected sound and reduce reverberation. Range of hearing or audible range. The human ear can hear the sound between frequencies of 20 Hz to 20,000 Hz. Thus, audible range or range of hearing is between 20 Hz to 20,000 Hz, for human beings. However, children under 5 years of age can hear the sound up to 25,000 Hz. Sound beyond audible range of human being, infrasound and ultrasound. Infrasonic sound or infrasound. Sound, below the frequency of 20 Hz is called infrasonic or infrasound. Infrasound is produced because of very slow vibration. For example, simple pendulum produces sound below 20 Hz. Human being cannot hear infrasound as their ears are not adapted to hear the sound of such range. Many animals, such as whale, elephant, rhinoceros, etc. can produce and hear sound having frequencies below 20 Hz. Ultrasound or ultrasonic sound. Ultrasound or ultrasonic sound, above the frequency of 20,000 Hz is called ultrasound. Humans cannot hear the ultrasonic sound. However, many animals such as dogs, cat, bat, monkey, deer, etc. can hear ultrasound. Bats catch their prey by producing ultrasound. Bat produces ultrasound and detects the reflected sound waves coming from any obstacle, such as a prey. By detecting the reflection of ultrasound, bat understands the position and type of prey or of any obstacle in the way. Some aquatic animals, such as dolphin, also use ultrasound to catch their prey. Use of ultrasound. Ultrasound is sound waves of high frequency. Because of high frequency, ultrasound is associated with more energy and can penetrate up to a large extent. This characteristic of ultrasound makes it very useful for many purposes. Some of its uses are given here. In detection of ailments in the human body. In cleaning of machinery parts which are beyond reach without disassembling of parts. Detection of any deformities in metal blocks. Detection of any blockade in pipelines. Sonar. The full form of sonar is sound navigation and ranging. This is a device which is used to measure depth of seabed, locate scraps, wrecks, submarines of enemies, etc. in the water by producing ultrasound. It is fitted over ships and submarines. Ultrasonic sound waves are produced by sonar, and when these waves return after reflection from anything in water, they are analyzed with the help of computer. The shape and position of objects under sea and ocean is detected on the basis of speed and nature of reflected ultrasound waves. Thank you. Please make sure to like the video and subscribe to our channel. We wish you the very best. Until next time, bye. Shape and position of objects under sea and ocean is detected on the basis of speed and nature of reflected ultrasound waves. Thank you. Please make sure to like the video and subscribe to our channel. We wish you the very best. Until next time, bye.